last idea for the day one of this lesson is finding the equation of a line. I want to know 2 points that lie on that line. Yes, I am aware that I learned how to do it a long time ago. The idea was before that I found the slope and then I used the point slope form. Let's see a different way where we use the determinant of a matrix. Suppose that we have 2 distinct points that lie on a line, and we put a third point. This is an arbitrary point, an unknown point, and because we don't know where that point is, we say it has coordinates x and y. The only thing that we know is that the 3 points are collinear. Since the 3 points are collinear, the matrix formed by placing the coordinates of those 3 points and augmenting 1 in the last column must have a determinant equal to 0. That is because, once more, the area of the triangle formed by using 3 collinear points is equal to 0. So, this is the equation that we would set up to figure out the equation of a line. Let's start. We are doing now example 5. Find the equation of the line passing through points 2, 4, and -1 and 3. We make up a third point that lies on the line. We say that that point has coordinates x and y. And what we do next is we make up a matrix. This matrix is x, 1, y, and 1, then 2, 4, and 1, and finally -1, 3, and 1. And since those points are collinear, we chose them in such a way that they lie on the same line, the area of the triangle is equal to 0. What do we do next? Well, next we have to decide what do we want. I will decide to use row 1. You can use any rows that you want. So let's say that the determinant of matrix A will be found by using row 1. So the entry in the first row, first column, times its cofactor, plus the entry in the first row, second column, times its cofactor, plus the entry in the first row, third column, times its cofactor. And all of this will be equal to 0. So A11 is equal to x times -1 raised to the power of 1 plus 1, times the determinant of the matrix that is formed by eliminating the first row and the first column. So this is 4, 1, 3, 1. 4, 1, 3, 1. Plus the entry in the first row, second column, which is y, times -1 raised to the power of 1 plus 2 times the determinant of the matrix formed by eliminating the first row, and this time the second column. Let's do so. The first row is being eliminated already. Let's eliminate the second column. This is 2, 1, -1, 1, 2, -1, 1. There we go. 2 and 1, -1 and 1, plus the entry in the first row, third column, 1 times -1 raised to the power of 1 plus 3 times the determinant of the matrix form by eliminating the first row, and this time we're going to eliminate the third column. So let's do that. When we eliminate the third column, we've eliminated all the ones, so we have 2, 4, -1, and 3. So 2, 4, 2 and 4, -1 and 3. Because I don't have any more rows on the right side, I'm going to put the 0 on the left side. So you have 0 is equal to x. -1 negative 1 raised to the second power is smaller than 1 times 4 minus 3 is 1 plus y. Negative 1 raised to the third power is negative 1. 2 minus a negative 1 is equal to 3. Plus 1 times negative 1 raised to the fourth power is 1. And then 6 minus the negative 4 is equal to 10. So 6 minus negative 4 is equal to 10. So we have our equation. 0 is equal to x minus 3y plus 10. You shouldn't stop there. You should be curious. Did you do it right or not? Quickly check. 2 minus 12. So I'm replacing x by 2. So this time we are checking. So check. 0 equals to 2 minus 3 times 4 plus 10. Yes, 2 minus 12 plus 10 is 0. Let's check with the second point. We have negative 1 minus 3 times 3 plus 10. That checks out as well. Okay? So this is example 5, part A. What I've done is I've made a different problem for you. This is not part of example 5. But what I did, I chose 2 points that lie on a vertical line, because what I wanted to show you is that even if 2 points lie on a vertical line, you can still find the equation of the line using this method right here. That's the end of the day 1 of this lesson, and so you've seen a lot of applications of determinants.